Today's lesson is over application problems that are demonstrating exponential growth and exponential decay. If you'll remember, the standard form for any exponential problem, either exponential growth or exponential decay, is the equation y equals a times b to the x power, where a and b are some number. So let's look at some word problems. It says we'll be graphing today and resetting the window frequently. Okay, this is on your calculator. We'll be doing this in class when you're working on the graphing calculator, but for now we're just going to work on getting the equation set up. And then in class we'll work on how to read your calculator to answer questions about these problems. When we work with our calculator, just keep in mind that the x value is going to represent the time, and the y value is going to represent the amount. This could be the dollar amount, the amount of growth, or the amount of decay. So let's look at this first problem. We have $300 and it's invested in an account that earns 5% interest, compounded annually. They want us to write an equation in the form y equals a times b to the x for the amount in your account after x years. So again, x is our years, that's the amount of time, and then our amount is going to be a dollar amount. So y is going to represent the amount after x years. Okay, so let's first write our equation. If you remember, a represents your y-intercept. So in this equation, a needs to represent the number when the time is 0. So this a is going to represent our initial amount. And then b is going to represent 1 plus or minus the percent. In this particular case, we have a growth word problem because $300 is being invested in an account and it's earning 5% interest. So we hope that it's going to be growing, that our amount of money is going to be growing. So the very first thing I need to decide is this a growth problem or a decay? Well, in this particular problem, it is growth because we want our money to grow. So in this case, b is going to be 1 plus the percent. And the reason why we use 1 plus the percent is because we want our initial amount, 1 times our initial amount, plus whatever percent we gain from the interest, we want it to get added to our initial amount. So this is going to be represented by 1 plus the percent. So let's first write our equation. We are going to have y equals our a, which is our initial amount, is 300, so we're going to put in 300 times, now I'm going to use parentheses, 1 plus our percent. Okay, so let me change color for this so that you can see the difference. The percent is 5% interest. I need to convert that to a decimal. The decimal right now is at the end of 5, so if I convert it to a decimal, I got to move it 2 places back, so it's going to be 0.05%. So if I'm doing 1 plus 0.05, that would be 1.05 that's going to go in here. And then I have it raised to the x power. Okay, so this is my equation. Let's go ahead and box that in. Now, in class tomorrow, we're going to talk about part B, find how many years it will take for the investment to double. But right now I want you to be thinking about what would the investment be if it doubled. So this is going to be when y, we want to know what's the x value when y is equal to double the initial amount, which would be $600. So tomorrow in class, I want you to be thinking about how you would do this on the calculator. And when you come to class tomorrow, we're going to do it together. So now let's move on to problem number 2 and number 3. So let's go ahead and get the equation set up. We'll do number 2 together, and then I'm going to leave number 3 for you to do on your own. Number 2, it says caffeine is eliminated from the bloodstream at a rate of 12% per hour. A cup of coffee has 150 milligrams of caffeine. Write an equation in the form y equals ab to the x. So is this a growth or a decay problem? Well, we would hope from the word caffeine is eliminated, that means that it is leaving the body, so that means that it's going to be a decay. Okay, so first off, this is a decay problem. Whoops, forgot my C. Decay. Okay, so in this particular case, A is going to be represented by the initial amount of caffeine. So initial, I'm just going to say initial. But then B, because this is a decay problem, this is going to represent the amount that is leaving our body. So we want to do 1 minus the percent because it is decay. So this is how we're going to set up our equation. So we have y equals, what is the initial amount that I have taken in? It's right here, 150. So we're going to put that in for A. Okay, so now let's figure out what percent we're going to use. Well, we have 1 minus 12%. Now 12% as a decimal is 0.12. So 1 minus 0.12 is what I'm going to be putting in here. And so what's 1 minus 0.12? It's 0.88. So I'm going to put that in here, 0.88. And then we just finish out the equation. We have parenthesis, and it's raised to the x power. So this is our equation that we're going to use for this problem. And then we can move on to part B. We'll work on part B tomorrow, but I want you to be thinking of how you would set this up on the calculator to solve part B. Okay, so I'm going to stop there. I want you to try number 3 on your own and come to class, please, with a plan on how to solve part B's of 1, 2, and 3. And I also want you to have number 3 done, and I want you to show that to me when we start class. All right, we'll see you tomorrow.